Welcome back, polar bears and polar cubs. Let's go ahead and talk about ionic compounds containing polyatomic ions. Well, if you are containing a polyatomic ion, you may find the polyatomic on the back of the periodic table in the upper left-hand corner. That is a nice little chart full of some commonly used polyatomics. Now, there is a group of polyatomics that are considered Oxyanions. So these ions contain oxygen in them. And we can actually change them from what is given to you on the back of the periodic table as an 8 ending. We can make them a ite, we can make them a per-8, or we can make them a hypoite. And that's what we're going to talk about today in our notes. So the first thing that we want to talk about is what happens if you get one less oxygen. So looking at chlorate, this is going to be our example. Chlorate has 3 oxygens. So if I lose an oxygen, I now have 2 oxygens there. What ends up happening is I'm going to drop the ATE at the end and replace it with ITE. So therefore, it goes from chlorate to chlorite. Now, on the other hand, what happens if I gain? So this is going to be a gain. Okay. Gain 1 electron. So 1 more electron. Now we're going to keep the ending of 8, but now we have to add a prefix. So the prefix then becomes per, meaning 1 more, and we add 1 to the 3, and it becomes 4, giving us perchlorate. If the last one is if we lose 2 oxygens, so it's 2 less, so 3 goes down to 1. You notice how we don't have to put the 1 there, so because we have 1 oxygen there, it is a 1. This one, you're going to change the ending of 8. Okay, you're going to add the prefix of hypo meaning a lot less, and then ite. So here's what I want to do. I'm going to go ahead and I'm going to make a nice little chart here for you. So we're going to start with a per-8. Then it goes back to the 8. Go ahead and erase that. And then 8 is what is given to you on the back of the periodic table. Ite would be the next one. And the very last one is hypoite. So here is our little chart. This means plus 1 oxygen. Okay, it's plus 1 oxygen. This one is on the back of the periodic table. Ite is minus 1 oxygen. And hypoite is minus 2 oxygens. So what I like to tell myself is that if I gain or lose an oxygen, one thing changes. So you'll notice that if I gain an oxygen, I add the prefix of per. If I lose 1 oxygen, I change the ending into ite. Therefore, 1 oxygen gain or loss, 1 change to the name. If I lose 2 oxygens, it becomes 2 changes to the name. So from 8, if I lose 2 oxygens, I become hypo. That's 1 change. And then the second change is I would replace 8 with height. All right. So that is how you take oxyanions and change them to the multiple versions of that one anion. The last thing that I wanted to do was go through some of the examples with polyatomics in them. So what's going to happen is I'm going to go ahead and do actually 2 of the top. I'm going to do the top 2, and then 2 of the names, and then have you do the third one in each one. So I'm going to change colors. So the first part of this is a polyatomic. It is NH4. So if you go on the back of your periodic table, the name for that is ammonium. And then we do I. So I is it's iodine, but we change the ending from INE to IDE. So it becomes iodide. The next one, the first part is PB. That's lead. Now, if I look on the periodic table, I notice that lead can have 2 charges. So I'm going to put parentheses there to just tell me, like, hey, I need to know what the charge is. SO4 would be our polyatomic here. Again, on the back of the periodic table, SO4 is sulfate. So we'll just write sulfate. And sulfate has a -2 charge. Since there's only one SO4 here, that means that lead would have to have a 2 charge as well. All right, we're going to do the name ones right now, and then I will give you some time to work on the other 2 examples before showing you the answers. So these ones, you have to find the charges. So it's kind of like a 2-step. So we find zinc. Zinc on our periodic table has a +2 charge. Cyanide is a polyatomic. It's on the back of the periodic table. It is Cn with a -1 charge. We're going to crisscross the charges, giving us a final answer of Zn, parentheses Cn2. When you have a polyatomic and you need to have multiple of them, like we needed multiple Cn's, the polyatomic itself needs to be put into parentheses, and the number of that polyatomic needs to be on the outside as a subscript. So let's look at aluminum. Aluminum on the periodic table has a +3 charge. Sulfate is on the back of the periodic table. That would be SO4. It's got a -2 charge. So we're going to crisscross. The 2 is going to come here. The 3 is going to come here. So 2 and 3, giving us Al2, parentheses around the polyatomic if you have multiple of them, and we need 3 of them. All right, go ahead and pause your video and try these 2 on your own. You'll see the answers in 5, 4, 3, 2, and 1. So for this top one, you have Ni is nickel. It has multiple charges. So then we look at HCO3. HCO3 being a polyatomic on the back. It has 2 names. It can be either hydrogen carbonate or bicarbonate. I prefer to write bicarbonate. It's just shorter. So then I write bicarbonate. And as an E. And the charge. So bicarbonate has a -1 charge. Since we have 2 of them, nickel's charge must be a +2. And finally, we're going to do tin. whatever this number is, carbonate. So tin, that number would be a +4. Carbonate is CO3 minus 2. You're going to crisscross them, giving you SN2 parentheses CO3 4. Now you might notice that 2 and 4 are both divisible by 2, so that is not our final answer. We need to reduce them, giving us SN parentheses CO3 2. Final answer. All right, that's it for ionic naming today, and best of luck on your worksheets. If you have any questions,